Hey, this video is about fractions and mixed numbers. Okay, so a fraction is a number that represents a part of a whole. It is the division of two whole numbers. For example, 3/4 or 3 out of 4 or 3 over 4, any way you want to say that, we can represent that with this picture. We have 4 parts of this whole circle. 3 of them are shaded. We're looking at 3 out of 4. So 3/4. The 3 in the fraction is said to be the numerator, and it represents the parts when we talk about parts over whole. The 4 in the fraction, the bottom, is the denominator, and it represents the number of equal parts in the whole. The fraction bar is a representation of the mathematical operation of division. It's funny because when you think of a division sign, it's usually this sign right here. It actually kind of resembles a fraction, where instead of a numerator and denominator, you actually have 2 dots. That's exactly what it is. Okay, Rick and TJ made a pizza in the oven and cut it into 8 equal slices. Rick ate 3 slices while TJ ate 5. What fraction of the pizza did each eat? We have Rick. He ate 3 slices. There were 8 total slices, so 3/8. We have TJ. He ate 5 out of the total 8, so 5/8. Okay, when a fraction is less than 1, just like these two fractions right here and the one we saw on top, it is said to be a proper fraction. And to give some examples, 1/3 is a proper fraction. 7 out of 9 is a proper fraction. Anything where the number on the top, the numerator, is smaller than the denominator, the number on the bottom. Okay, when a fraction is greater than or equal to 1, then it is said to be an improper fraction. Some examples of that, maybe a number like 8/3, 8 over 3. We might have a number like 5/2 or 5 over 2. That's an improper fraction. They're greater than 1. They represent a quantity that is larger than 1, or you can think of it as being to the right of 1 on a number line. There are some properties of fractions that we should know. And so the letters here, the letters A and B, just represent any numbers that are not 0. If we have any number over 1, represented like a fraction, A over 1, it's going to be equal to that same number. Example, if we have 3 over 1, we can simplify that fraction, get rid of the over 1, and just say that equals 3. It's kind of the same as multiplying by 1. When you multiply something by 1, it's the same number. So how we said fractions were division, if we divide by 1, dividing by 1, we get the same number. Okay, 0 over a, 0 over any number is going to be equal to 0. So any fraction that you have a 0 on the top is going to be equal to 0. So if you have 0 out of 12, that's equal to 0. Now, the opposite of that, if you have any number over 0, so you have a 0 in the denominator, that is interesting, very interesting in math. It's actually what we call undefined. Because fractions represent division, if you divide by 0 in math, it doesn't make any sense. There's no way to handle an operation like that. So it's not 0. It's not a value at all. We just say it's undefined. So if we have anytime we're working on a math problem and we have some number over 0, then we have a problem. We can't continue with that. There's going to be some kind of error in our calculations, or if we want to get technical, we want to say that it's an undefined value. We can't divide by 0. Okay, anytime you have a fraction where the numerator and the denominator are the same exact number, like a over a, in this case, it's just going to be equal to 1. So if we've got 15 over 15, we can, well, we're really reducing the fraction. We can simplify it and just simplify it to 1. If we're dealing with both positives and negatives, which sometimes we have to in either in arithmetic or in algebra, if you've got negative a over negative b in your fraction, the negatives will actually cancel out. So you're going to be left with just a over b. The same way that we've talked about when you multiply two negative numbers, a negative times a negative, you get a positive. Well, in this case, you're actually dividing because fractions are division. You're doing a negative divided by a negative, you end up with a positive. So if you're doing a problem and you have like negative 1 over negative 3, you can simplify that by getting rid of both of the negatives, making them positive, positive 1/3. And then another thing about the negative sign is if you have a fraction that's negative, like a negative, any two numbers, a over b, you can either put the negative sign on the top, on the numerator, and then leave the denominator positive, or you can put the negative sign on the denominator and leave the numerator positive. Either way, it works out. It's the same exact number, the same value. So say if we had like negative 3/4, I can rewrite, if I need to, I can rewrite negative 3/4 as negative 3 over 4, or as 3 over negative 4. All those three fractions there with the negatives either on the numerator or on the denominator or in front of the entire fraction are representing the same value. Okie doke. So in addition to proper fractions and improper fractions, we also have mixed numbers. A mixed number is the sum of a whole number and a proper fraction. But when we write it out, we don't put the plus sign in between. But if you have something like 2 and a fourth, it's the same. It's equivalent to saying 2 plus 1/4. That means the same thing as that. And if you want it represented visually, say we're back at our circles that are divided into fourths. Now we have one whole plus another whole. That's 1 plus 1 is 2. And then we have a fourth of our last one. So again, that's representing 2 and a fourth as a mixed number. We just don't write the plus sign in between. If you look at this example down here, if we want to write this as a mixed number, so let's see how much we're dividing into. We have 1, 2, 3, 4, 5 total parts on the circle. 2 of those 5 are shaded on the last circle, and then these are in 2 entire circles that are shaded. So this is a quantity 1, this is another 1, and this is another, this is actually 2/5 or 2 out of 5. So if we add all that together, we end up with a mixed number. We can represent it as 2 and 2/5. Occasionally we have to convert back and forth between improper fractions and mixed numbers. So when you have an improper fraction and you want to change it into a mixed number, there's a little procedure we can do to do that every time to get the right one. We divide, because fractions, again, I've said this over and over, fractions are division problems. So we'll divide the numerator by the denominator using long division. However many times the denominator goes into the numerator is the whole number part. And then the remainder, for using long division, the remainder is going to be the fraction part, and we're going to keep the denominator the same. So, and hopefully there's enough room to do this here. Let me go purple. So we have 20, in this one it says Rebecca ran 23 over 3, or 23/3 of a mile. What distance did she run as a mixed number? So if I divide, if I say, well, 23 divided by 3, do a little long division, we have 3 goes into 2. It actually does not go into 2, so we move to the next digit. So 3 goes into 23 how many times? That would be 7 times, right? Because 3 times 7 is 21, right? 3 times 7, 21. So if you subtract and get right here, you've got 3 minus 1, which is 2, which is your remainder. So you could write that as 7 remainder 2, but when we write it as a mixed number, we're going to keep the 7, the whole number part. Then we're going to use this remainder, what was left over, 2, and we're going to write that as the numerator. We're going to write the denominator as the thirds. So we keep the same denominator we were working with when we had the improper fraction. It's like we were dealing with thirds the entire time. We're still dealing with thirds. So we found out we had 7 whole and then 2/3 left over. So 7 and 2/3. And we can do the same thing for a negative. If we have negative 27 over 4 or negative 27/4. Let me switch to a different color. And just so I have more room, I'll do it up here. But 27 divided by 4. We say how many times can 4 go into 2? It doesn't fit into 2, so we'll move to the next digit. 4 goes into 27. Let's see. 6 times? Because 6 times 4 is 24. So we can subtract that, get our remainder. We have 7 minus 4, which is 3. So as a mixed number, we have our quotient, which was 6 as a whole number. We have our remainder, which is now our numerator. And then we have the divisor there, which was now the denominator stays the same. So because in our first part of the problem it was, oh sorry, I almost forgot. This had a negative in it. So we can do the math as if it had a positive, but then at the very end we'll just put a negative sign out front. Negative 6 3/4. Okay, so to do it the other way around, if we want to convert a mixed number into an improper fraction, which occasionally we want to do that because if we're doing other math with that fraction, it's easier, say, to multiply 2 fractions together if you're using improper fractions instead of mixed numbers. So so here's the 2 steps. We want to get the numerator of the improper fraction, or to get our numerator, we multiply the denominator with the whole number. So let me see if I can use a highlighter here. We multiply these two, the whole number with the denominator, then we add that to what's left over here in the numerator, that becomes our total numerator. And then just like we did before, we keep the denominator the same. So two examples here. If I've got 5 2/3, and I want to convert that into an improper fraction, I can do 5 times 3, that's 15, right? 5 times 3 is 15, and then add the 2 that was remaining on top. Keep the denominator the same. 15 plus 2 on top. 15, 16, 17, so 17 thirds, 17 over 3. So once again, we multiplied the whole number times the denominator. Then you add, after you multiply, then you add the numerator here. If we do that same step by step, if we have negative 7 1/4, and again, it's a negative, so our final answer is going to be a negative. But we'll do the same steps. Here we'll do negative 7 times positive 4. Let me switch to a green. So negative 7 times, or let's actually forget about the negative for now. We'll worry about it at the very end. Our final answer is going to be negative. So this is just think of this as 7 times 4. That's 28, right? Plus 1 that we had remaining on top. Keep the denominator the same. This is eventually is all going to be a negative. So 28 plus 1 is 29 over 4 is our improper fraction, and it was the original problem had a negative, so this one's a negative. I usually just keep the negative for the very end, because when you're multiplying, that might get confusing at first. So anyway, yeah, 7 times 4 is 28. 28 plus 1, you add the top, gives us 29. So it was 29 over 4, and it was negative, so it's negative 29 over 4.